Okay, I want to finish up lecture 8. We spent some time talking about how we determine what the relationship between two molecules is. The last is going to be, okay, once we've determined the relationship between two molecules, what does that tell us about them? What does that tell us about the way they'll behave, what their properties will be like? So, remember, constitutional isomers, how do I tell when two things are constitutional isomers? Yep, different connectivity. So constitutional isomers have different connectivity, and what that means is that gives them completely different properties. I mean, sometimes their properties might be similar, but it can often lead to wildly different properties. So physical properties will be different, often very different. And then chemical reactivity, they're going to react completely differently from each other. And then we have this broad category, stereoisomers. Remember, stereoisomers have same connectivity. But different arrangement of atoms in space. For stereoisomers, often the properties are more similar than they are for constitutional isomers. But it's also going to depend on which kind of stereoisomer they are. So what were the two broad categories of stereoisomers we separated into? Diastereomers and enantiomers. So when you have two enantiomers will actually have identical physical properties. Remember, these are mirror images. So physical properties like melting points, are identical. Melting or boiling, those are processes that really can't tell left from right. It doesn't really matter whether you have left-hand molecules or right-hand molecules. They're going to behave the same way in that circumstance. Their chemical reactivity will actually be the same in most circumstances, but not in all. All right? So it depends on what kind of thing they're interacting with. And this is where I would use an analogy of your feet. Okay? Feet are chiral. Most socks, unless you have those, there are some socks that are designed for a left foot or right foot, but most socks are achiral. Whereas shoes are chiral. When you put on your socks in the morning. Both of your feet interact exactly the same way with your socks. Doesn't matter which sock you choose, which foot you choose. The feet and the socks interact in the same way. But when you're choosing your shoes, it matters which shoe you choose to put on which foot. And that can be a hard thing for us to learn when we're like 2, 3, 4, 5, sometimes 6. But the idea is enantiomers will behave the same when reacting with achiral molecules, but they behave differently when reacting with chiral molecules. So chemical reactivity is the same with achiral molecules, like your socks, but chemical reactivity is different with chiral molecules. And then diastereomers, these are non-mirror images, so these are any stereoisomers that aren't mirror images or diastereomers. These will have different physical properties and different chemical properties with any reagent. Sometimes the properties are still very similar, but they could, in theory, be very different. And we'll come back to these principles when we study specific reactions where they become relevant. All right. So that's the end of Lecture 8. Are there any lingering questions?